a some intro, quick cell intro because there are new people here. And then the follow-up format will be we'll recollect her for 5 to 10 minutes. The thing's a short paper, so 5 pages or two. And then we'll just fire up the stage for our Q&A and then discuss about this idea and brainstorm what can be built on Calculus Supreme. And if you don't have the paper, it should be available on Luma. There's a cool dotted link. So yeah, I'm like, I'll start with the first Solidity. Hi everybody, I'm Connor, Cut Researcher at Proof Lab. I'll also establish here at P. And Brian, yeah, work at Portal Labs as researcher, stuff happening here. I'm Paul, I'm a software architect, product architect at Sei, and I was previously at Polygon Labs helping Brian with this shit. I'm Vivek, I used to work at the Vallejo University where I do that project called Thermal, which is applied researchers and by people who are computation. Oh, it's the Hey guys, I'm Alvaro working for Polygon Labs and also the founder of dApps. Hello, Justin. Formerly a finance professor at NBC University and actually just doing unknowingly I have a smart bot here. I'm very shit spraying. Hey, Young York. For equilibrium, it's a blockchain on you. Ryan with policy on the blockchain. That's all. I am Alex Saki Gabriel at the. I'm Joe White. I'm a PCIG, a banking research lobby. I Brett, an venture investor with PCUC Sage with BQs and the company net tobacco probably very said to you. I take both those. When you see sponsors, but so does he. Oh. Yeah. I have provided. Popon show. I used to work with that. You actually don't like the front photo. That's not a weird thing. No, he does. Have you seen what a whale is doing? No. I know. Also, many more this kids on alcohol. Don't the work is right. But he was lost.
It's the same company as that. They started faucet.
Just upper on an endless cat sick. I stick. Take Israel always pamikiran now with kasi.
Well, I'm Kevin, and we're building a book platform on what?
Nissan, I do machine learning at dApps. I'm Shabi, I'm the angel and general partner eConventions Peppermint based in UI. And I've been visiting the searcher to visiting researcher. Okay, that's the positive way up way. Oh, what? Net John Shane. Oh, you're Jane and couple. Wow. What? Please. Hey, brother Marcus, I'm with whatever Lee. Oh. So I don't know if everybody have the chance to read the paper. So we're just going to take 2-3 minutes. It's a very short book.
Like independently? We just read it and this is the
Read it, Al. You need bedtime.
I think we should open that way. Steve. It's just too loud. Oh, that door? Just one side? So we can try. Oh. And I see. Genius.
This gay, please.
Apologies, please.
À, Beats.
By the way, in the paper, there's in the components like the table, I modified it from balanced paper, so yeah, proud to delete the proof delivery and computation. So that's not part. Shoes judgy tier. No, yeah, maybe I show. Stop trusting him. Okay. I think it's time. There. Need a little more time? Was there? Or does 2 more minutes? Okay. Right. Hope the summary makes sense for most people. I'm just gonna do a quick 5-minute washer and then we'll just dive into some of the more details. Alright, so the inspiration of Chainless app come from a lot of discussions internally with different people, especially with Paul G. We together kind of thought, okay, now that we've been trying to scale blockchain as much as possible from inside a blockchain, where there's a lot of but inside it there's a lot of limitation in terms of programmability. It will be limit the solidity and gas limit and a lot of those. And from user experience would be the gas, you have to pay the gas fee, and then there's a volatile gas fee where it's not fixed price. And then there's also limitations of how much computation you can run. So there's a lot of limitations in a company if you try to develop and improve inside a blockchain. And with the advancement of zkVMs and some of these like verifiable computation concepts coming in, which includes not just zkVM, but with TE that we cover in the morning. And also there's Icon Layer, which does sort of a community-based computation verification, which is not ZK, but just a different security profile. With all of these different security primitives, consider as the sort of a relayer that you can bridge any off-chain that is not on-chain computation, but you can convert them into actually a trustful and something that you can trust on blockchain. So it's converting this off-chain computation to an on-chain computation, this kind of a conversion. This is where we think the zkVM, TE, and a lot of these could happen. But once you start doing this, then you start to have a lot of communication problems between on-chain and off-chain states. So there has to be some way of it's just like how layer 2 and layer 1 communicate with each other, where layer 2 is considered off-chain to layer 1. So there's that sort of communication part that needs to be implemented. And then also at lax. So all of these off-chain computation, if we generate a zk proof and I have a zk proof of my computation, I send it to just someone randomly in this room. Everyone else in this room is not going to trust two of us only. So I have to settle on somewhere there everybody can trust, where if I send it to, instead of someone in the room, I send it to Ethereum, that Ethereum is something that everybody trusts. Whatever thing that randomly Ethereum finalized is something that we can relay the trust onto. So that's where we have the settlement concept coming in. So with this context, we figure we can actually build an off-chain computation framework that actually has the blockchain level trust, but has the performance and capability and the programmability, all the good things about Web 2 stuff, endpoints. And that's why we call this a chainless framework, which is a Web 2 level capability in terms of user experience, computations, programmability, but underlying the trust part is a blockchain Web 3 level trust. And to achieve this, we have a couple layers of separations, just so from developers' perspective, you can build it with ease. And from actual this trust relayer maintainer's perspective, they can just focus on the trust part, which includes the execution layer. It's on the Web 2 or whatever application developer side that they maintain. And then once they have produced some sort of execution trace or just like footprints, they can throw these footprints to a trust layer, which could be ATE service provider. It could be just law department too. That's an extreme case, but ideally the current sort of the POC that we're trying to build is zkVM based. And then moving on, once you have this, you also need this sort of a communication mechanism. So integrating into some of the existing bridge solutions such as app layer as this example, or even in future we could tap into some layer 0. This could be configurable, but just so that we're not again creating a fragmentation of liquidity and fragmentation of just like different trust environments, but it's that they're from day one, when the app is deployed, they're connected to blockchain since day one and they can communicate freely. And the last but not least will be all of these cannot exist or cannot be trusted if they're not settling on somewhere that is a decentralized or trustful place. So it could be a DA, like a Veil, or it could be an Ethereum, whichever your choice is. But if you really want to communicate and transfer assets, we might want to settle directly to something like Ethereum, so that for a faster communication. So those are a little more on the detail side. And I guess in this discussion, what we're trying to discuss is, with such framework, we have some examples in mind, but I'm more than happy to explore some more potential use cases because we think this verifiable app will be sort of the next phase of building trustless applications, not just building on top of Solidity, but Solidity as the state verification, just like a portal. But most computation and application logics and services happens off-chain. And that's sort of the main idea. And
let me take a step back.
yeah.
I want to just clarify something first, right? Maybe like when you wrote the paper originally, like what was the initial motivation? Did you feel that, was it like just purely like the user experience thing, or did you feel that something existing was broken that could not work well, or were you thinking along the lines of something else?
I'll start first, and then I pass it to Paul G. He probably has a lot of opinions of his.
He talks about this people.
You regard the longest salty people in SBC.
Yeah. There's a lot of things that I'm trying to achieve with Chainless. But me working my first career in crypto as a DevRel, of course, as the developer experience was just like, there's only so little things that I can build on top of this Solidity or blockchain architecture. And it cannot scale, and it's the user experience point. it's just very limited compared to the Web 2, where if we actually want to adopt more users, you got to be able to catch up with the Web 2 level experience or with the current stack, it seems like, and it's kind of hard. So maybe finding ways to go around the blockchain, but also use this go around the limitations of blockchain, but also still use the most important thing of blockchain, which is trust. I think trust is what the most important thing about blockchain, and we should just use that mostly. But the rest we should happen somewhere else, but try to bridge these together. And the second is privacy. Everything happens on blockchain is public. There are different ways to input on privacy, but it's all kind of gimmicky. It's all a little bit like, it's a hack. It's not a very general approach. Whereas if you just do offchain computation, that itself is private by default or confidential by default. Maybe not private to the operator, but that's how our Web 2 currently runs. But we just need to make sure that the operators who are running those services, they cannot do weird things with those private data. And that's why we had the verifiability to ensure this sort of robust execution atomicity. But yeah, I'll want to.
I want to hear question.
So how is this different from Aztec? And then how do you compose program on top of each other? Is there options?
Yes. So first off, it's like, I think from the top level, like you could read this and be like, it's Polkadot or something, right? Like at the end of the day, like from day one of this stuff, we've been talking about whether or not you have like basically a shared execution environment or a sharded execution environment or separate execution environments, right? On Aztec, you can have basically the shared execution environment, right? So you get possibility. It's nice. I have a philosophy that is kind of driving some of these beliefs, which is that like for a long time, the thing that we cared about was decentralization as like a primary focus. But where we're actually at in blockchain application development today is that decentralization is not the only good that we're trying to go after. And in fact, most of the applications that you guys all interact with on a daily basis are not decentralized at all because they all have private keys that are controlling their upgradability on this very decentralized network anyway. So you fundamentally have a trust relationship with an application operator that is existing in a shared application execution environment. Now, the execution environment might be trustless, it might be decentralized, all these things, but my relationship to you as the deployer of a particular smart contract is most of the time these days is that I trust you to not run me one way or another. And so the thing that I care about today is less about decentralization as like the top level goal, and I think it's more about sovereignty. I want users and application developers to be able to make the decision about the contract between each other such that it works for the user experience or the developer experience that's required for that use case, right? But here's a great example of this. If you're building a video game, one of the core things that we try to get in like Ethereum is censorship resistance. In a video game, you do not want censorship resistance. In a video game, censorship is your product. The thing you're trying to build is a good experience for video gamers. And if you make that censorship resistant, you create worlds where people get to fuck with each other in ways that make the game not fun anymore, right? This is the same thing with a social network. The core product of a social network is censorship. The core product is curation, right? So if I want to build an application that is serving my users, I might need to choose to sacrifice censorship in some case. I might need to have this sort of behavior. So when I look at it, I'm thinking like, okay, I want people to be able to make those trade-offs, and I want them to be able to build an application that has that. And for the most part, many applications work very well if you build them. It's like kind of like centralized manner in terms of like I'm communicating, some information to you, it's doing some computation, etc. But we also want to give people the ability to like add trustlessness to it if that is necessary for their use case, right? Now, the problem is that like app chains have been around forever, right? As a concept. Normally, the way that we had to get to app chains was having some shared VM environment in order to make that app chain thing work, because you needed some level of the ability to like know what happened on an app chain was correct. And you've got these like it can poke it out. You have these big environments or in Ethereum, like everybody still runs EVMs. And I look at it and it's just very inefficient, right? Like the place that we're actually in right now is that everybody went through this round of trying to build separate ecosystems because of the monetary incentive that's involved with like running an ecosystem. There's basically like more money on the table. Still today, there's more money on the table for building an L1 that is completely uninteroperable with anybody else and no applications than building a good application, right? Which is just fucking stupid. And so I'm looking at this just thinking like, how do I maintain this first from like a Web 2 perspective of building something where I can create a contract with my user, right? So then on top of that, we need to layer things like interoperability. So I care about sovereignty first, and then I care about interoperability next, because I actually think there's more solutions to interoperability, right? So in this paper, we talk about Egg Layer. Egg Layer was the product I was working on at Polygon, and it was supposed to be a solution for shared interoperability, where if you exchange ZK proofs in a particular way, we could create like asynchronous or synchronous composability. But also you could just use message passing via layer 0 or wormhole. If I have a ZK application and I can produce a proof, I can also just like send that proof to somebody else. So I think there's like other solutions there. So really what this is solving for is just like this sovereignty component. How do I build the best application for a particular use case? And usually I would say today, like the best way to build applications for particular use cases sometimes is like a Solidity app in a shared environment. And sometimes like in the Hyperliquid case, right, is like a very optimized order book in memory, blah, 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 blah thing that does something different, right? In the case of a video game, nobody wants to write a video game in Solidity. That's stupid. But they might want some part of their video game engine to be verifiable because that's interesting, right? And so this is just trying to talk about that problem and like it, where we care less about the interoperability than the sovereignty start. I don't know if that answers that question, but it's a philosophy thing, right? Like,
I was just gonna say, because that's from what I'm hearing, I think there's like an interesting thing where, there's always like a triangle of life. What are the dilemmas of life? There's always a triangle somewhere. But I'm wondering if this is kind of, or if it's not, whether it's the various philosophies like privacy and sovereignty and trust and usability. Like, are these all? Like, do these all fit well within one world, or is there trade-offs that you fundamentally have to make where if it is very performant, let's say, then you cannot have composability, or if it is very private, then you cannot compose. I don't know. I'm just thinking out loud.
no, I don't think that's 100% true. Like, so I work at Sei now, and we're a hyper-fast L1 that provides full composability across everything, even though it works really, really fast. The trade-off there is like we do need to agree on an execution layer, right? So I guess maybe you're right. Yeah, there's like a bit of a trade-off to sovereignty, right? Like if the best way for me to write my application is like, I don't know, NetBeans Java for 1998, like, sorry, you can't deploy that to Sei. That's not a problem. But so yeah, I guess there's a little bit of that.
How does the chainless app?
Hey, you can make it a chainless app. This is what I'm saying. Like, wouldn't it be amazing if it was like there was some like whatever, like the best way for me to write this application is like literally like a Java JDBC drivers, and like you just pull it off the shelf and do it, and like you can still actually interact with the blockchain applications in like a conceivably reasonable way that's explainable to normal devs.
Yeah. And also like interacting with blockchain wouldn't mean like you need an RPC or anything. All you need to do is just use the Chainless SDK and then say, hey, send transaction, chainless.send transaction. And that's about it. The rest of like the same developer program experience.
Yeah. Yeah, there is an assumption in here that there is some interoperability layer, the egg layer specifically, right? But that could also be LC or something.
Well, I will come back to.
Yeah. Do you have any insights on like the demand side of such verifiable apps? So that from where my question is coming from, there was this concept of like micro rollups, which is like
It's the same.
similarly on like transform the app sector. Yeah. So like you transform any application into like a state transition function essentially, and then you program it as you would traditionally like in normal Web 2 app. like whatever language you want, and then you add this verifiability. But I'm not sure why it didn't receive it as mature adoption as it was supposed to. So like they are putting insights on.
So the current demand, so I'll come back to the state transition function in a bit. So that's so that comes down to use case purpose. How should I define the interface for developer to build their applications?
Actually, my answer to this, but yeah, okay. So the real answer is economics. Unfortunately, the answer to all of our technical questions is like economics, right? There was not enough of a market because there wasn't enough of a use case where this was 100% required to make happen. So there was no demand for it, right? The demand for the last 10 years has been fork Uniswap, add a token, extract value, right? A lot of it. Now, we are seeing this use case happen, and specifically because of the need to be faster, and Hyperliquid is all of our example, right? And so what we're seeing now is the development of these things, like Hibachi is a great example of it, GTE, etc. We're seeing this where it's like, okay, Hyperliquid made a different set of trade-offs, right? They've got 2 servers running somewhere. We're calling that decentralized. And we're going to match a bunch of orders really fast. But what it's pushing us to do as a community is to say that like, this other way of building, like the trade-offs we were making before that were good enough for the market are no longer good enough, right? So I do think we're going to be pushed there, specifically on the perp dexes and the speed. I don't think that there's a market there for a lot of other use cases yet. But I'm wondering if there could be. One of the things that's like very interesting about like the proposals from Vitalik to use RISC-0 for the VM for Ethereum based roll-ups and all those things is that effectively you have the same structure as what we're talking about here, where you're saying like what we care about is less about building applications in this like one particular VM, and what we care about is the ability to show that some computation happened and then settle economic value between each other, which by the way is like the same thing Avail's doing, right? So there's a bunch of players now that are kind of focusing on this because I think like we look at it and it's like people are less satisfied with copy pasta. But in order for it to work, we need to build a framework that can be copy pasted enough that these like core primitives that not everybody needs to rebuild.
And also just adding to that, the way, also talk to Stacker Flat, like we were thinking about and why is it fail?
Yeah, why did Stacker fail?
I'm gonna say it failed, but it's more so of like, it's all about finding its use case, like what he was talking about. And then here comes Saga Blast, who just made an announcement at their 1.0 SDK. But if you look at their code, it's still the state transition function, but it's hyper-focused on trading activities, which is what GTE is built on top of their stack. So it's like they found a niche market to go for, and then they eventually made it available for people to actually build up. But it's the same thing as Sector's Lab. Maybe just a little different in terms of how they sequence, just like the Summer Lab is much faster in the sequencing as outro. But because that's what they focus on, because they focus on trading, and what they needed is the speed and the verifiable execution. And GTE landed on this use cases. And assume
for those that are not familiar, what is GTE?
Yeah, GTE is a verifiable exchange that once off-chain is not written in Solidity, is written in Rust, but uses the Sovereign Labs SDK. And essentially, Sovereign Labs SDK is a fantasy machine. It's basically, you use that to define, here are the states that you can host. And then from different state, this is how you can transition to different state, those state transitions. And then you apply that as the state machine. So that's the custom VM. And then you run that VM. And if the VM runs successfully with all the state inputs, the execution trace you provided, then it's valid execution. So in another word is an order book that runs not on EVM, but on a custom VM built on top of Rust. And it's the same thing as what micro-rollup is doing, but it's much, much faster for the sequencing, which is what the order book application really needs. And Eli,
Is this what you wanted to ask about use cases, by the way? Like, I think to me, it's like the idea is not new or whatever. It's like very obvious. But the thing is, it's like, I think we're in a spot where maybe there's use cases where people are more interested in now. where like this becomes the nicest way to build them. I'm actually interested from Avail. Are you seeing any cool use cases for this sort of thing?
Yeah, I think a lot of people are now trying to become the next Hyperliquid and so on. So that's one. But people are also seeing, off-chain financial apps being, just custom state written functions rather than being completely on-chain. Completely off-chain ledgers basically. So that is happening more and more often. And especially if you think about, why does a Robinhood want to deploy a rollup of their own? It's essentially an off-chain ledger that you want to operate, which being verifiable. So you can think like, okay, why is Robinhood deploying a full EVM stack? They might do with a
Yeah, they already have a database, probably.
they can run a custom stack as them. But my question is more like, I saw on the glossary that the mentions are an SDP mentioned right now. What is the delta there? What does this do differently than a sovereign API, for example?
So I guess like when we're writing this paper, I guess like it was kind of early. The GTE and everything, it was kind of a low key in the market. It wasn't very well aware, but just 2 or 3 months after, now it's like such a boom.
Yeah, there's also the VApps paper from there's zero. There's another whole framework, dStack.
Oh, these are called TE.
Yeah, right.
And then Eigenlayer is also doing the Eigen Cloud, which is actually quite similar to Tom's new team. But eventually, I feel like of course, like from their end, everything has to follow the state transition. There's no parallelism by all of those. But in a real world use cases, there might be a lot of parallelism happening. There might be different state machines per application. Then for them, it's actually just a custom rollup. It's not and it's kind of limited to that use case, which is fine. And I think they find a good product market fit for it. But Chainless is more of a concept which includes this kind of framework, but also it could be different things. So, I mean, at least from my perspective, it's about figuring out the use cases. That's one. And I cover a little bit about privacy, and also it could be microtransactions. And all of these could actually be different states that exist in this app, like per account base, that this can't be compatible with the rollup architecture they have, right? And so yeah.
I have a question actually, which is like, does anybody have an application that you're like, oh, I would totally build that, except for I can't really do that right now on this particular, either the SBM or EVM or something like that? Do you have one that you wish you could just build?
It's not directly answering that, but it's kind of related question. Just like, because you're talking about like for an application, right? So I decompose it into different parts so that they all different layers do this. I think in practice, like really useful application, they're really, really large. And thinking about how to decompose that itself, it itself becomes an engineering challenge. So I wonder how do you address that? And also I'm just like, because you talk about zkVM, I'm just curious about any test you do in terms of performance.
He actually did quite a lot. He benchmarked all of the open source zkVMs.
All of them, but yeah,
All of the under 4 months ago wrote it.
yeah. Now there's more, but it's not 40. Oh, really? What? Yeah, no, because for catching other issues are not yet. So yeah. But performance-wise, I guess like it really depends on the application and what kind of, I guess like, if you're using a lot of signature, if you're using a lot of like hashing, right? It depends on that. The performance matters a lot. But usually like right now, if you just use like a normal free compiles that those zkVM supports, and also a lot of the hash algorithm they support slow, then it's not too slow. And if you're doing like, I don't know, what was it? It was like 50K or 100K transactions for an order book, then it's like 7 seconds or something to actually generate a proof. That's because everything is the same format and same consistency. And our state model for that order book, it's just very simple. It's not like an EVM where there's a lot of different bytecodes. If there's only 5 bytecodes for this custom order book zkVM model, custom VM model that runs on zkVM. But yeah, this is not publicly available yet, but it's just we're testing some of the designs.
Yeah.
So it's actually quite fast.
To your point, like people generally and enterprises generally like don't do large things unless they're like forced to do so by a regulator. some kind. And like I was talking to the Yoruba earlier during his Whitepaper reading, and he said privacy with compliance, and like I argue that Hyperliquid is popular because they're not enforcing QoS. 100%. And well, and HLP, the liquidity flows, the half-leaves resistance, and like that's going to frustrate to Hypergate. And like the point at which we have regulator gate, like, okay, all health insurance applications on the web have to now be verifiable. And like that's the point at which we have demand. And like it's kind of like a max nihilist like point of view, but like I've been there for tough ages now. So
Yeah. Yeah, it is difficult, by the way. You're right, to like decompose the different layers. One of the things that we were working a lot with, like on zk. So one of the things that I helped build at Polygon was the type 1 zkEVM implementation, which was like a hand-rolled zkEVM. And like one of the key things to question in all these designs is like where do certain types of verifiability and certain types of performance match? Like, is it okay just to do it in a TEE for your particular use case? Is it okay to do it in a TEE for like n seconds and then have lagging zk proofs? Is it okay to just have some case where there is like a mini consensus committee of like 4 entries for something? So yeah, it's a whole design space. But the thing I like about this is that like it's like moving past the design space of like I have some validators and an EVM and hopefully it all works.
I think that would be a challenge, like, just to your question.
Yeah.
I want to go back to his point there. What are the odds? What is this dilemma, trilemma? I think, security and interoperability sometimes comes at very odds. Then, for example, you can say that I'm sovereign, an application is sovereign, the operator set is sovereign. But the moment you come in a layer 0, they take away sovereignty in the sense that whatever the layer 0 operators and nothing wrong with theirs. Whatever they decide becomes the state that they want to enforce, and we are no longer sovereign. If you
It's a good point. Yeah, it's kind of like the whole like now that we have DeFi, Ethereum's not forkable.
that I mean Ethereum is portable or not, if the other hand is sort of
value is
and they say like no, it's not. When can base roll us the optimistic kind you heard that?
I mean, the other way would be you build your own bridge. Like that could keep your sovereignty, but it also sacrifices the custody, or I mean the legalness. Like you have to bear that risk. So it's either you delegate it to someone else, then you have to obey their requirements. But hopefully they're minimal to your application's implementation, or the other way around would be you just take on everything. But yeah,
I actually assume, and like I know people building, like there's a lot of people building this model now. I actually assume that most of them will have just their own bridge.
that's what Abashi's doing. Yeah, and it's a very, very ridiculous, simple bridge. You can only bridge USDC only, you know.
Yeah. So yeah, the use cases I think about obviously exchanges. Very interested in this video game case because it's like I think this like blockchain gaming thing I've always thought was sort of dumb. But sometimes the things that I think are dumb end up working, and I'm like, maybe there's a world where there's like something interesting to pull off here, you know? I literally don't know what it is. I'm not a game designer.
And the game example is a perfect case of what he was mentioned, that it's very hard to decompose. The state of a game might be bigger than Ethereum's total state, right?
You're right.
A sufficiently big modern game.
Oh, this 100% bigger than that by, yeah. So or make, yeah.
I actually explored trying to break the old game's second life that they do, or ancient. And you talk about that, taking that and making that a blockchain game. And it's literally the problem taking this ancient, like, written into JDK in 1994 or whatever. And then wasn't that written like twisted Python or something like that? It's truly messed up, like my life. But like it's got this like sharded game server design where each world is like this little, 256 by 256 hot apple. You gotta figure out how to like take all of that and then make it verifiable. And like kind of adjacent point. The thing that like the second industrial revolution was the creation of the relational database. When it's like how you take any system that's using a relational database and trying to do a chainless.
Okay. The reason this started was because I was like, I need a demo for egg layer. And I was like, we should write Google Sheets chain. I was what? Google Sheets chain, right? It's a Google Sheet. You pass it through a zk circuit to produce a, yes, this row is added, removed, whatever. And now it publishes that information to egg layer, which is like an interoperability layer. And now all of the balances are publicly available, right? There is actually work on verifiable relational databases. I think the performance problems involved are what get you, but like maybe we'll get around that. System programming works, right?
Well, like Space and Time D, like they've got cool stuff, but it kind of relies on the data in the simple database being blockchain data and inherently verifiable. Then it's
Because it's stored in a Merkle IGA or whatever. Yeah,
exactly. And like, I'm literally working on that freaky central mortar book, and like we got the same problem of like we got this crazy Postgres database. You're Merkleizing all this stuff and then just shoving the Postgres database and then taking it out so they could do the root transition. This interruption. It's like you run into this problem of like, okay, on your cryptography, just trying to like figure out which chain encryption we should be using.
Yeah.
Space and Time uses quite a bit of cryptography that's to make sure that they're very performing.
Yeah, like their accelerators, like next level. Mandolin still like 2 always. Yeah. So if the space and time is fully verifiable, well, you get the things crew boost. And how worse it is in terms of, I guess it takes more time to query their database.
I think I saw a number. It was like in the tens of millions of percent.
Oh, really?
Yeah, I'm sure. Oh, that might be faster. Yeah. Woo, they solve it for us. Yeah. For blockchain.
Yeah, for blockchain, yeah.
But do you have any thoughts, comments? No? Maybe, no? Just want to make sure that everybody... Oh, you do. Sorry, please.
I'm not a technician, so I have concepts like misunderstanding. What do you mean blockchain is? So, I need a picture. So for me, I was involved like sales industry. So you saw say about GT, your campaigns like my family or almost something. Right now I see like there's two like J gaming with charging with USDT Bitcoins like one ACR. You play poker. And there's another one. Yesterday my friend showed me smart area called Double Up, but then you can charting with like Sui or those kind of stuff. Is that means blockchain game? Is there not?
Yeah, so the use case for blockchain games basically ended up becoming like gambling games because there's gambling kind of games, but then there's also like a lot of what happened is basically some form of I've got a game running. As a result of taking some action, I get an in-game item. I get a sword, I get a shield, I get whatever. I win in a war, and now I'm going to mint that as an NFT for ownership. And we're going to try to create like an interoperable ownership layer that's separate from the video games. But video games themselves, inside the worlds that they create, like there's value in there's one of the things that's happened a lot in the last few years. I'm not a big gamer, by the way, so somebody should correct me if I'm totally off base. But like all video gaming is now online, which means that all video games are basically like able to be turned off by an operator of that game when it's no longer profitable. And we've entered a world where over like every 6 months, I hear about some big old game that everybody used to love where the operator's out turning it off. And so the way that those systems was designed was inherently centralized and controlled. And it means that there's no way to shift that burden onto the community in an easy way. And so the simplest thing for them usually to do is just to shut it off. And I've been kind of wondering if these tools existed well enough, if you can create systems that would be easier for them to transition, and then there would just be good. If you could actually run these game worlds, or like the complex part of the game, in a way that wasn't like architected just to be operated by this one. That's kind of what I'm wondering about. It's a much bigger idea. I just don't know. I don't know if there's a market for it, but I do like regulation. Like if there was like, if the EU said every single video game that's published, they must be able to like, the game servers must be runnable by the community.
You know, they're literally bins right now.
Oh, are they?
Yeah, Paul is a whole petition. Stop killing games.
Okay, stop killing games, right? Yeah. So like if stop killing games works, then all of a sudden there's a technical problem that needs to be solved, which is how do we do this? And like I think the solution looks something like what I talked about.
Maybe a thought that I have is, I feel that over the past, let's say like 6, 7, 8 years, let's say just on Solidity, the development patterns are kind of recognized. So you deploy a contract, you have a front end that updates the state or reads the state from this contract. Maybe you have a server that serves the front end and it does a little bit of calculations or with some stuff on the database. In this new model, what do you think that, let's say like the website and the app architecture will look like?
It would look like a Web 2 application with an application server. Like there's a billion people that know how to develop that application.
So where would be the part that then, let's say you tip the state and then put it on chain, but where would that happen? Well, when would that?
This is why I think we need the verifiable Postgres signature. So you can just settle the state root of your Postgres database, so then every whatever it is 7 seconds. Yeah, it should literally just be like, like I'm not exactly sure how TA will work in that particular case, but how will look a lot like this BSRP, but you need to settle like proof loops, like all the data required to do a state transition or assisting proof, and that's kind of it. I think there's a lot of different ways of designing it, depending on the applications. That the most efficient way would be just existing database, but we convert them into a verifiable one, and then we just commit that state. Or there's a lot of system logs that is producing per application. That also can be produced as well as like a verifiable traces, and then you use that as to convert this app into a verifiable. But this is assumption, of course. So it's like it's easy to think about it. Then when you actually think about it, then how do you actually make sure these logs are sort of just like, how do you design these logs so that these logs are actually be able to produce logical state transitions? That is a challenge.
I did it there. So that 2018, 2019, I did research, wrote a paper, verifiable Postgres. There were a bunch of papers, LHE and others, a bunch of papers on verifiable logs, exactly on similar things. But I think they were not performant enough. I have not seen them rise now, but I think we can take cues from there. And because one of the things that they presume is some of the ordained decentralized and stuff, at least on the idea paper. I think today's rollup is essentially that.
Okay, it's essentially yeah.
So at many they all can be taken now. And
Well, I mean, we've literally had a 10,000 to 10,000x speed up in zk proof generation since 2018, right? Something like that. So yeah, maybe those ideas are just more doable now.
So then let's say in this case, right? Let's say we do have everything, and then we have verifiable like Postgres, and then we store this on some data layer or some other service. Who's consuming this data back? Is it like another application? Like for guys,
Ben Fish from Espresso Systems had a great tweet. So probably like 4 or 5 months ago now. But verifiable computation is best suited for a situation where you have a single party that is proving something to greater than 100 parties that do not trust you. So enterprises, in my opinion, don't have this property. It's like small and medium business. It's individuals who are trying to prove something to an institution. I don't know necessarily what you're supposed to do with that iteration, but like I thought it was really interesting, like fun.
my take is a bit different. My take is like, where is consuming is essentially when you have multiple applications, how does they talk to one another? The one application, we need to verify the state of the other application. And they are essentially the consumers of all these bits. So we keep on thinking like, settlement, what you defined as settlement, and Ethereum being verifying all of this. You can think of it that way. Or you can think of a world where there are many, many sovereign applications, each one of them consuming others' data inputs.
Yeah,
Maybe, but then
I think it's not.
This in this world, like one of the things that, and like this didn't maybe go that well internally in Polygon, but I was like, actually the whole, because we wanted everybody to settle to the egg layer, but like from my opinion, it's like settlement as a concept disappears under this environment. Settlement is more like a horizon that you choose, which is like this set of applications has proven to me that X has happened, and now I can take my next step, right? It's more of like a graph than it is like this singular settlement thing, which is also a bit tricky because I think it decentralizes in the other version of the word, like Ethereum, right? Or the value of that validator set.
So then in this case, then, would it be the idea that actually everybody is just building a component within a bigger sort of like emergent system? Because in the idea that if I'm pushing my state to this, to something, and then somebody else will be building on top of that and doing something with that, then we're kind of a part of just one system. Like Uniswap is not doing lending, let's say. They just focus on trading. They could, right? But for some reason they're not, and then ours are true, right? I mean, like in the Web2 world, you kind of just try to own everything, but in this world, we're always kind of saying, hey, you just own a small piece. Like maybe your character or something, just like you're responsible for just their clothes or something, and then another part of this game is responsible for the weather, and then you're kind of building this mega universe together. And in that world, maybe I'm just trying to think.
Yeah, and I'm sorry, those are it's I don't know. I think there's a concept here. It's like it might be something called like the web, right? So like for all of us that built Web 1 and Web 2, it was like it's like we're gonna have public APIs. They're gonna be consumable. You're going to share this data. And what happened, and again, back to philosophy, things move through decentralization and then centralization. Decentralization is innovation. Centralization is where you extract profit. And we did this in Web 2, where we built these emergent systems. There was a bunch of APIs and systems that would talk to each other. And then Facebook basically said, Zynga's making all the money. We want the money. We're shutting it off, and we can trash it. And I think the interesting thing is that we can do this while we can like force ourselves to keep the openness, because there can be financial exchange because of the openness, right? The only way to do this in Web 2 is to centralize because of like the dynamics of the system, but we can do it differently because we have programmable money, right? So I think that that's much more likely where we're going, or I'm hopeful that's much more likely. Can you describe that now? Which thing? Decentralization, centralization, Facebook?
What's the point in the argument you're making very specific?
Oh, the argument that I'm making very specifically is that this thing that we're trying to describe is like the same goal we had with the web, right? A decentralized system where, different actors could have applications that are sovereign that people work with, but there's ways to interoperate. The thing that was missing from the initial vision was money, digital money, even though it was supposed to be a part of all the specifications, we never got there. And what it meant was that because you couldn't provide value along this whole part of the chain, the system was incentivized to centralize all that value into big verticalized stack.
Can you give an example?
The big verticalized stack is Facebook. They were incentivized to capture all value of that in a verticalized stack and turn off public indexing. They were the first major platform to teach.
Twitter access.
Just to provide a counter opinion here, is that on Web3 we are seeing the exact opposite, where you have seen someone like a GT, which was mentioned quite a bit, moving out of Mega ETH. And people are saying, and this is not the first time, but Jupiter has...
These are just like not philosophical. These are very vague descriptions, are right? Well, you're discussing proving information. You want to make it look like Postgres. I'm just trying to see how it connects to what you're about to.
Nobody cares unless there's money involved. Is right. So I think it is.
Well, we were talking about interoperability, right? Why are we building interoperable things? Right? We're not building interoperable things. Yeah. We're not building interoperable things because there's more There's more money in non-interoperability if you're the winner that captures the market, right? The reason you need verifiable Postgres is because because having verifiability creates the ability to do interoperability with money exchange.
What are you verifying here?
Well, for example, if you have an exchange, we're verifying that my trade actually happened properly.
I mean, what are you verifying here? Are you about reports or what are you about?
Any changes to the data.
Yeah, you change the database, yeah. Same thing that you're verifying now with blockchain.
I want to make sure that all of the messages in my DMs actually came from the person that you're getting with, and they went from the person we're dealing with into the data.
Obviously, from the it's verifying the metadata too, like who changed it, when.
I like that's like an indication detail, but really the thing that's important is I want to make sure the data can go point A to point B to point C to me. And there was a complete, honestly, it is verified now. So the is basically verifiable.
I mean, if you can set up with the you don't have some way to like make sure that like somebody changes you don't know.
We can guarantee that data like you showed they are from past assets. So you can't guarantee that the data wasn't categorized in the database.
I mean, this works fine for very well. I mean, I agree. I think for 99% of use cases, until regulator steps in, it'll be satisfied. Unless there's money involved, in which case capital efficiency.
I mean, unless CloudWatch just works fine.
Okay.
For verifiable, right? So
I think we can move this off chain. And this discussion can go off route, right?
Yeah, we can do it.
I think there's something there. But I want you to just finish your point earlier. Right?
But also, I think of this, we are seeing the opposite direction where you start with being general purpose and you have these applications. These applications don't be big. They start seeing the value that is being extracted by the platform and then not getting enough out of it. Then moving on to become separate applications and then going through the same trouble of it. Again, having ecosystems which are general purpose again. We have seen that with Jupyter and Solana now creating JukeNet. We have seen them in last 2 days with GT maybe moving on to Mega, that's what the rumors are. We are seeing that Uniswap moving out of Ethereum, Unichain, and this will continue. So that's the exact opposite of what Facebook did with Zynga in that sense.
It's very interesting.
It can. So, yes, I think this maybe the probably fun because as I put it to here, I how about the question you're trying to solve before, but I'm not sexy. So, so for me, I was thinking like in Tether, we already have the kind of the like Oculus, the glasses. Like if you go to the sea and they have the data like the real actual, they're just talking the glasses and they order about Uber, about butter pool, everything, and then they payments the same devices all because it's or it's like a mini percent party everything's dictation like in WeChat you can instead of communication and the payments like a bank key too. So in China is already doing this. But I was thinking if you want to experience like the Web3 and Web2, the real world experiences, like every database is changes that we need to trace more. Actually, it is electricity. The database means you need a lot of electricity to storage as all the data is. Maybe it's the electricity's problems and also means physics.
It is in fact a physics problem, specifically because the amount of computation overhead, the amount of extra computation you need to do to provide verifiability right now literally costs too much, or maybe costs too much until like very time. Well, the time is cost, right?
Isn't the cost like constantly going down though? Yes. That like I feel like every 3 months I see this thing say, all right, we cut it down by like 80%.
Yeah, it's significantly going down. Maybe once we get like the binary field things implemented in certain cases, it'll get faster. GPUs are accuracy. Yes. So this is kind of the point where like I think we're going to get to the point where at least we're already to the point now where for some applications, like let's put it this way. Right now, Katana is a layer 2 blockchain for DeFi trading, and it is a zk rollup. It runs at 1 second block times like base, and they do full ZK verifiability of every state transition, right? That's right now a feasible way to operate a blockchain. So like that was not the case 4 years ago.
So let's say now this is and then noise. But this is like the initial version.
This is kind of composing a framework, an idea to how to like paragraph thinking.
Yeah, it's more like a way of thinking, I would say. And then these are the possible components in this world. If you had to extrapolate this to like another, let's say like 3 years or something, what would that kind of look like?
Like what are the components that we would expect to exist?
Yeah, like what are the things that need to be there in order for this to work very well? What are the things that need to be taken away? What are the changes in behavior for developers? I'm just trying to think in an experience perspective.
I get to you. For me, it's like I think at the end of the day, the reason why first Vercel became Vercel today is because there's a matter for the website, right? Everybody wants to post a website, but they want to do it as fast as possible, and that's why they have one-click deploy. Is now that SH to deploy it. Eventually, they call it Vercel, and it should be something like that, where first the demand has to be created, and GTE and some of these like Apache is a good example for it. And with the cost going down, like we're talking, we hope that this is going to be sort of that use case. And also the compliance side, right? If that's a demand, say, hey, every app now, the data should be interoperable instead of owned by a centralized company who will stop doing the monopoly, then there's such sunlight for us. Or, it's a window for us to adopt it. So we be ready for it. And with that in mind, it kind of has to have that proper experience, say, just one-click deploy. It's something that is just so easy that you don't really need to learn blockchain. You don't need to learn about AWS for server. Just use our SDK, and here's all the preset of config and everything. Just deploy, and this is the same. There's a realistic implementation.
Yeah, I think we need, maybe to counter what I said earlier, I think we need the interoperability layers that exist to kind of like have settled into a steady state, right? So that there can be a stack that like, I like spin up my Rust program, I do my things, I take whichever verifiability solution that's a zkVM, that's a TEE off the shelf, which is, those are the components which are currently now being commoditized, right? TEs are commoditized, zkVMs are commoditized, they're become. So we take those off the shelf. The interoperability right now across this is not quite there yet. There's a bunch of different takes on it. Most of them are still like, there's a 5 of 7 multi-sig somewhere, mostly. So you kind of want to get rid of that at some point. There's a bunch of people trying to do that. There's Boundless from RISC-0. There's Avails work. There's Egg Layer from Polygon. Layer 0 is trying to add this sort of stuff to us. So I think you need that. You said identity. I'm wondering where you think identity fits into it.
Like what the global verifiable internet looks like in 10 years is almost exactly what the global internet looks like today. We've got OAuth, we've got identity providers, we've got the ability for a guy to communicate with one another. We've got an SDK that wraps that set API. I think it was a lot like npm install workcoin login. I think it will.
Yeah. And like, you mean Claude, I need to have WorldCoin login?
Yeah.
Yeah.
I mean,
I know you said that like facetiously, but it's like,
no, but yeah.
actually like, login and identity and simple attacks over resistance is like a huge problem.
Yeah.
And
Payments across those rails, I think. They wanted X402 from Coinbase.
Why the identity things are popping up right now? Regulators. Save the kids, make sure everybody's got their age, verified on whatever account they're logged into, unless that is the reason see venture capital and dump it and just builds value. It's right now.
Yeah.
The next thing they regulate will be the next thing that's verifiable and so on and so forth. That's my approach.
Well, one last question.
We're in a touch. I'm curious, like, where do you guys think like people should be focusing their efforts in ZK? Like everyone, like I feel like the main focus for the last 2 years or so has been like Kuber networks. Saint and RISC-0 and other teams have built great proof systems, but who's to say that these proof of networks are actually going to be useful or viable or, actually sustainable in the long run? You've got lots of teams that are consuming ZK or integrating ZK for identity or otherwise, right? But they're not necessarily touching a lot of the lower level ZK. They're using survivors, SDKs, whatever. Like both in terms of having impact in the ecosystem as well as having success for yourself as an entrepreneur. Like, where should people in this room be spending their time focusing on like what ZK needs next?
I have two very specific things. One is latency. So this is like the work that Jordi Bailina is doing on ZIS, right? Is like if we take a zkVM solution, but we want to focus specifically on latency, we need to get down further than we currently are. The second one, and I think this is unfortunate, is that we might need to do something like formal verification. If we are going to actually put the world's value behind these things, you either need reasonable, cost-efficient multi-proof strategies, and some level of formal verification of these systems, because it becomes very, very costly. It'd be like breaking TLS or something like that, right? So I think those are two areas that are just going to need to happen. A lot of the rest of it is, interestingly, I think, systems programming. And what I mean by that is like it's a simple matter of continuing to pay the people to do the stuff they're really good at, which is optimizing low-level things, etc.
And by improving those two things that you mentioned, do you think, like if I were to work on improving those things, do you think I can actually monetize that or progress this? Or is this a research problem?
Maybe not in your lifetime.
Yeah, right. And so that's the hard part, right? Is like where should be people focusing their time where they can both monetize their work and like maybe
this is why prover networks exist, right? Because there's no other business model. You need to make a token, so you make a prover.
Yeah.
And so that is a little bit.
What about Cornado Cash though? I feel like that was the only use case of on ZK set.
That was monetized, and we saw what happened.
Yeah. They didn't have privacy with bytes.
There's another.
You could have I mean, there are both something out there. It's kind of like bad. There were two.
I mean, yeah, I think the places where there's potentially businesses is basically like where this intersects with payments in the real world, which currently is also like intersecting with the agent work, right? So, for instance, like again, there's X402, the 402 code from Coinbase. There's A to A. How do agents talk to each other? All of those things, like verifiability of agentic operations and thus the payments attached to them. Like, I mean, whatever. Agents are just like bots, but like we're dumping like billions of dollars into making better bots. So like maybe if we're looking at business, there's something there. Like how do we make actual verifiable agentic commerce?
So when you say they're formally verified the ZK, the correctness of the corrected job, yeah.
So I think it depends on the application of it, which you're using the ZK correct for. So for example, if you're dealing with like a government client and they need to, there's from stories, you found a confidential secret and you're using ZK, like that's something that's going to really need to be formally verified. So it could be a business or some kind of consulting for that, but you would have to, I would say, tailor your clientele or to not just like, I'm just formally verifying zkVMs out there.
Right.
I'm curious the other speakers if you guys would also say the same focus or if you guys have other perspectives.
At least for me, like the application is what I'm focusing on because I feel like, there's a lot of talents in blockchain space. Everybody's focusing on infra, and you get wet for a coolest technology, but it's like, that doesn't really consume it, right? And I think, I don't think ZK is the focus that we should have, honestly. It's just like all these techs out there, how can we use it to build full application that is kind of unique to blockchain, like calling market. And that's my short thing and my only focus.
I think that if you want to be an entrepreneur, you should be building an application, getting customers into your revenue, and like worry about, swapping out the back end, like it's faster or whatever, if you use UT there or whatever, would better. But I think in terms of research, like needing to be like pushing forward on MPC, ZK and fully global morphic encryption, all of it at the same time, because pretty much are visionaries. If you combine in two of those things, like, you know, we live in free and the future. So they're all confidence.
Yeah. Thank you.
you. And if you are super bullish on all of that, on the research side of things, I think they should also go hard on hardware because you see the current trajectory of AI where every device has this, not only the GPU, but now also where APU or whatever that is called. If you think why some of these primitives are so popular as it is today, because all the hardware providers have really, outputs for them. Like the hash is so fast because they have like all Intel and Indian, everyone has done that. If you think you can go that deep tech, probably you should, and that's a gold mine out.
But thank you.
Oh, Arbits. Yeah. I have an extra idea. KYC with CK. I mean, I guess we are all tired of sending a copy of the passport in PDF, right? So once you mix zero knowledge with that, I think solving KYC is a pain point. Who has it? They solved it. They published it. But it's not like fully recognized by a regulator, right? I mean, you can't open now a bank account with KYC.
Oh, that's true. No, I get. I can't bring that to the airport and be like, okay, let me piece it here.
No, you can't. Yeah, can you? Oh, yeah. It counts as you can do it as in the U.S. You can use their passport credential as a real ID.
Okay, you mean over in a border?
Yeah, from the United States, it will work as but I think you still need your passport when you use it in other country. So you can use it as a real ID, not an international travel.
Okay, yeah.
Right. I'll stop. Well, muchas gracias.